Hello and welcome to video number 27 about how to make a chess program in Go. Last time when we look at the result, I was a little bit suspicious about the numbers. It was maybe a little bit too good. This time I decided to make the function Perft. I will describe later what that is. It's a very useful function to find out if you have any error in the move generator. The function is already written, so I will just show how it works. Okay, we can remove these things. They are done already. Null move. And we look at the UCI commands. And as you can see here, I have the Perft, but I have a lot of other commands. I'm not sure I ever show them. So let's look at all the commands that I have here that are not UCI. So we start the program, and now we have the start position and PB, print board. Print the current board, and PBB, print all the bit boards. So here we can see the bit board for the black queen. It's a black queen there. And we have print moves, PM. It's 20 moves, and here they are. It can be useful to have these commands. And evaluation is 0. It should be in the start position, and QS is 0 as well. We have a C command. The C command needs a move, so we can say E2 to E4, and it's 0 also. The key, the hash key, both the hash key and the full key, and the index into the transposition table, and the lock value. And if we print out the history table, it's currently empty, so let's create one. And here is another command, pose fill, that I have. For the tests, I have pose fill, I have pose English, and I have pose London. Now let's go depth 10 to fill up with killer moves and transposition moves and so on. And now the history table should have some values. If I write hist, I get the history table, the top 50 moves and the values. I have sorted them. So A1 to B1 is a white move, it's a rook move on the top. It's because we have such a bad evaluation function right now. I have another move val that prints out all the moves and gives different values for the moves. The history value, the C value, the delta PC² tab, the PC² tab that we use in evaluation. You know, where the where the square and piece in combination has a special value, and the delta value is the to square for this piece minus the from square for this piece. And in the end I can see what kind of move it was in the move generator, transposition move for instance. We can see the negative C values. That means it's a move that move the piece to a very bad place. And Perft. Here is Perft 2, and you can see the total is 1192, and then the Perft for each move. So let's set the start position again, and a Perft 1, and that is, as we know, 20 for Perft 1. If we make Perft 2, it will be 400 because we have 20 moves, and for white and for each move, there are 20 moves for black for each white move. And Perft 4, for instance, gives much higher values. And here is no alpha, beta, no nothing. It's all the moves down to apply for. So the start Perft is our starting Perft function. The start Perft can be compared with the root function in when we make a search. It's the root search. And that's because I print out the value for each move, the Perfts for each move. And I'm using our normal move generator, the next normal, because that's what I want to test. We could do this much faster without order the moves, but for me that's not so interesting. I have comments here. They are for debugging purpose. If there is a problem, if the number is not correct, the number of moves is not correct, I have this code to track that, and it's comment. And I print out for each move and the total. Perft can be compared with the search function. And when we reach depth 0, we return 1. In all other cases, we make the move and call Perft again. So it's a recursive function. No alpha, beta, no nothing. Just every move possible to do. And of course it's only the legal moves. I have more comments here. That is the code for make the debugging easy for these if there are some problems somewhere in the Perft. And as I said, Perft is a recursive function, the same as search. We don't return any evaluation, only the count. So let's start the program again. I forgot to mention one more command that is not UCI, and that is moves. So we can make all these moves, E2 to E4 and so on. And this is the Ryle opus. We can make a Perft 3, for instance. We can see each move has its own Perft, and in the bottom we see the total. And this is the next function. So, for instance, in the end we have all the bad captures. But right now this position has not been filled. So we just make a go depth 8 here to fill up with killers and transposition table to be sure that we test the real situation with the move generator. So the first one here is the transposition move, and then follow the non-capture and so on. I have this file. I have a small collection of positions and the Perft values. As you see, the start position, the Perft 1 should be 20, Perft 2 400, Perft 3 8902, down to Perft 13, and it takes forever, but it's a big number. I have a small collection of 6 positions that captures most errors you can do in the move generator. If you want more, you can search Google. You search for Perft. Maybe you need to say Perft chess engine or something like that. This is all for today. Have a good time unit. Until next time. Bye bye.